Reverse engineering is often a complex task, demanding a large number of different processes. Many of these processes require computer software to perform efficiently. As a result, a robust collection of engineering programs is needed for a successful reverse engineering operation. We utilize a wide array of software in our workflow in order to meet any engineering challenge. Out of all the computer-aided design or CAD software on the market, Solidworks is an industry standard and market leader. A large suite of modules makes Solidworks a robust tool for many steps in the engineering process. In our engineering workflow, Solidworks is primarily used for creating models of physical components. Parts are measured physically and then replicated with parametric modeling. If an object is composed of multiple parts, models can be combined to form assemblies. Afterwards, drawings of the parts and assemblies can be created, which are used for both inspection and manufacturing instruction. The software can also be used for generating animations to demonstrate machinery operation, performing thermal or stress analysis on components, creating highly detailed renderings of objects, and a host of other applications. If 3D scanning is used to digitize a part, software such as Geomagic Design X is required. This software is able to import scan data as a mesh. These mesh files can then be reoriented, combined to form larger meshes, and cleaned up to remove imperfections. Geomagic also has the option to perform parametric modeling in the same environment as the mesh, allowing a designer to quickly and accurately generate a CAD model for manufacturing reference. Scanned meshes can also be compared directly to a CAD model to inspect for physical deviations. If large quantities of parts needs inspection, more specialized software like GeoM Inspect can be used to compare multiple samples at once and to perform more comprehensive deviation analysis. Other specialized engineering software includes programs like GearTrax. With this software, mathematically exact gear tooth geometry can be created that conforms to any existing gear standard. An engineer can take measurements of a physical gear, input the results, and have the program generate an ideal gear model, which is exported directly to Solidworks. The program can also generate inspection criteria for part verification.